So without further ado, Chris Mikolajczyk from Princeton Hydro.
Good morning, all. I'm a bit of a wanderer, so if I'm in the way, just tell me to move. My wife does no problems doing it, so I'm used to it. It's not a problem. What I want to talk about today, dredging, small part of the big picture, but why having a management plan opens doors. Yes, even to funding, right? Quick introduction slide. I'm a non-certified lake manager. I've been with PH for 25 plus years, 35 years in the field, a handful of degrees, a couple of elected board positions, including NOMS, which is North American Lake Management Society, a continent-wide organization of lake scientists. But I call that my wife and mother slide, because the only people that care are my wife and mother. So a quick quote. Anyone who can solve the problems of water will be worthy of 2 Nobel Prizes, one for peace and one for science, right? People are easy, right? You as Management Association people, you know that. People are easy. So I want to start off with a little bit of a story. And it relates to lake management so well. In the early 90s, I graduated college. I was still chasing the pro hockey dream. I was dating my wife at the time. I was complaining to her that every time I got punched in the face, an old cut that had been either stitched or stapled or glued shut would open back up, and I would bleed again, and it was just getting to be a pain in the butt, and I was really tired, and I wished there was a product that could be used that could solve the problem, and I would stop getting cut. And she looked at me dead in the eyes and said, "Here's an idea, stop getting punched in the face." That's when I knew I was getting married. But if you relate that to lake management, every harmful algal bloom is a punch in the face. Every invasive species infestation, that's a punch in the face. Sedimentation is a punch in the face. If you keep trying to band-aid those things that occur in your lakes, you're just going to keep getting punched in the face, right? You've got to figure out how to stop getting punched, all right? And the NOMS definition of lake management and lake manager refers to a person who manages a pond, lake, or reservoir and its watershed. That's the key, and its watershed. Makes decisions that affect the quality and uses of the water body, right? And I'm not going to go through the whole thing, but you've got to look at the big picture. Short-term, water body, long-term, watershed. So what is a watershed? Everybody knows what a watershed is? I don't have to go through that? Good, we're okay there. So how do you determine a watershed? Eyes, boats, maps, photos, computers, satellites. Us, we use GIS programs. We can map it out like that, all right? But it's essentially, anytime it rains, if it rains, when it rains again, it ends up in your water body. So I'll switch over to dredging now real quick. DEP defines dredging as the process of removing sediments, wetlands, or open water soils from the bottoms of body of water, mechanical, hydraulic, or pneumatic tools, right? You need to understand with regards to the DEP and regulations, definitions are key, very key, all right? That's how things are regulated, by definition, all right? The goal of dredging is to restore and maintain the original bottom contours of the water body, all right? I need to stress that as well. If you choose to dredge, you cannot go beyond the original bottom. There's several reasons for that. One is ecological. 2 is if you have a dam, your dam was designed for the original water body. You can't put additional pressures on the dam. All right, any questions so far? We all good? All right. So the process, and this was probably covered last month, a bathymetric survey, permitting, design, specs, construction, as-built plans afterwards, sediment management, plans, bidding, monitoring, all of it comes into play. Now I'm going to use a bunch of pictures from a dredging project. I literally just did the final site walk yesterday. It was for Mercer County, one of their flood control water bodies, Mercer County Parks, 45,000 cubic yards of sediment came out of the water body. All right? So we have a bunch of pictures I'm going to include to show how things are and examples. So you start with a bathymetric survey. Bathymetric survey maps the water body, water depths, sediment thicknesses. The sediment thickness map is the first tool you will need to go into dredging with regards to your plans. Everything the DEP wants to see is based off your sediment thickness map. If you don't start off with a solid foundation in terms of plans and permitting, you'll be behind the 8 ball the whole time. So these maps are done a couple different ways. Typically they're completed in NAVD 88, which means they're based on elevation. All right, same thing as surveyors use. You have a set benchmark by a surveyor. You have a GIS GPS system with a dual frequency echo sounder. Takes a data point every second. All right, or you can do hand probing, which in areas not conducive to sounding. All right, so when we do a survey, the sounder is mounted on the boat, and the boat just does transects back and forth. And that sounder is taking a data point once every second. 2 different signals, one measuring the water depth, second one measuring the sediment thickness. Now, in areas you can't use the sounder, you go to the hand probing, which is done with GPS and literally by hand, as it says. Here's a couple of pictures, just some examples. On the right, you've got the sounder being used. And you can see everyone sitting back having a leisurely old time as the sounder does all the work. We're setting the benchmark in that middle picture, and on the right is the hand probing. This was a bathymetric survey we did near my house in Colorado. Everybody was very happy to come do that one for some reason, but you know, it doesn't change. It was a little interesting to set the benchmark at 10,000 feet in the air, you know, elevation-wise, but the process doesn't change. A couple examples of the bathymetric surveys. This is that Mercer County lake I was just talking about. This is the water depth map, right? So it's a 3D map, water depth, the brighter the color, the deeper the water, and you've got the contour lines showing 1 foot elevation differences, right? So obviously the north end, deeper water, the south end where the inlet is, shallower water. Now, the sediment thickness map for that, flip it. All right, darker brown, thicker sediment. The lighter brown, less sediment. So down where on the south end, where the inlet is, the stream comes in, things get washed in, they hit the standing water, settle out. That's where the dredging was focused. All right. That Colorado reservoir, here's the water course. This is a 5-acre lake, all right? And all it is just a glorified dam stream like most lakes are. But you can see the deeper water going off to the right and kind of snaking around. That's the original stream bed. In this case, it's a river, but that's the original flowing water bed. So the shallower water up to the northwest, that's where you'd expect to find the sediment. In this case, opposite. The sediment was actually settling out on the northeast side where the main river channel's coming in, right? So this 5-acre lake, there's over 20,000 cubic yards of sediment that are ready to come out, all right? The Mercer County lake, which is 100 plus acres, 45,000, right? So 20,000 within 5 acres versus 45,000 within 100 acres. Every water body's different. So once you get your bathymetric maps, you go to a sediment sampling and analysis plan. This is a DEP approved document saying, here's how we're going to collect our sediment samples, here's what we're going to analyze it for, what do you think? DEP will review it, they'll approve it, they might make changes. This tells you how you can manage that sediment once you start dredging. Where can you put it? Do you need to take it somewhere? Can you use it over here? Can I put it over there? This is what drives your financial decisions, right? Most dredging projects, 3/4 of the cost, transport and disposal. Where are you bringing it? Mercer County, I got very, very lucky. First time in 30 years, 100% clean sediment. The farm fields that were right next to the lake are now 6 feet higher. All right, saved them a ton of money. That project, soup to nuts, everything, permits, engineering plans, construction, transport, disposal, less than 1.5 million for 45,000 cubic yards. All right, and I know the cost is what can scare people off. All right, that was everything. Well, there's some chatter going now, huh? So your SSAP really drives your costs. Once you know how much sediment you have, what's in it, what can I do with it, then anybody giving you a scope of work can hit the ground running and tell you how much it's going to cost, probably plus or minus 5% at that point. All right. Unfortunately, for me as a consultant, the frustrating part is not being able to tell a client how much things are going to cost until I have all that data. So the Mercer County Lake, this was the actual figure from the sediment sampling and analysis plan. All right, we did a series of grab samples. Grab samples get analyzed for physical analysis. Composite samples then get done for chemical analysis so that you can save some money with the testing. All right, pretty straightforward, very simple. Permitting. It's everyone's favorite word, right? Nothing? All right. Again, going back to the original lake bottom is what your max is. The permitting, most people think your permitting is because of the removal of the sediment. And yes, you're right. But the biggest problem with regards to permitting is not the actual dredging, it's how is the machinery getting in and out of the water body. All right, do you need to build a temporary access road? Are you going through someone's backyard? Do you need to go through an easement? Do you have a launch ramp that maybe can be used, right? That's where the problems come into play, because there's not a lake in this state that doesn't have a wetland or a transition wetland located around the edge of the water body. You need wetland permits for that. And when you disturb a wetland by putting in a stone driveway, for example, you now have impacts, which means you have mitigation. All right, I mean, listen, I don't have to tell you all, it's navigating the bureaucratic regulatory maze. So, and this was covered last time, I did see the slide. You typically have your lake dredging permit, your flood hazard area permit, your dam safety permit, if you're within 200 feet of the dam. Most times you're not. Something that gets forgotten about, if you're doing mechanical dredging, you typically have to get a water lowering permit. Well, if you get a water lowering permit, the conditions of that permit mean you have to get a fishery salvage done, where you save the fish, which means you need a scientific collector's permit and then a stocking permit to put them somewhere else. All right, so you need a permit to take them out. Once you got them out, you need another permit to put them somewhere else. Your county soil conservation district comes into play with regard to erosion, sedimentation control, and you might have an Egyptes permit if you've got a particular certain acreage of disturbance. So the water lowering permit. This was the Mercer County Reservoir after we lowered it, right? And you can see, this is where all the dredging was to occur. This is the main part that stayed in play. Luckily, we did not have to do a fishery salvage because it was determined the area left behind was large enough to sustain fish through the course of the winter and spring. This particular water body also has snakeheads, so I was really not about having my crew having fingers bit off. So we didn't have to do it, luckily. But you can see, once lowered, it's pretty straightforward. It's a soupy mess at times, but once it starts to dry, it's just a dirt moving operation, right? Any fishermen in here, or fisherwomen? Put them up, you're all right, you're okay. What do you see here?
No fish.
Besides that?
No structure.
No structure. Remember that. A couple slides later. So when you do have to do a fishery salvage, you get that collector's permit and you get that stocking permit. This is my crew, Jesse, on the right. He's very passionate about his job. Those are carp. When you get a collector's permit and a stocking permit during salvage, if you come across carp, koi, or goldfish, you cannot move them. They are considered invasive species. Now you have to dispose of them. That's a good time. What do I do with 1,000 dead carp? There's all kinds of answers. I'll just leave it at that.
What's the main answer?
What was that?
What's the main answer?
Usually they get humanely euthanized, aka they're put in hefty bags and into a dumpster. We have done projects where local farmers have taken them and dug trenches. They're fantastic fertilizer. Don't ask them that, but one of the best projects I had was I gave them to the Raptor Trust in Millington, if anybody's familiar with that. They used the raptors that are a little more fish specific. They use them as feed for them. I've seen zoos take them and sanctuaries take them. Still makes me laugh. The best use I've seen of them is they are frozen solid, right? Deep freeze solid. And during a heat wave, the larger carnivore animals will get them as a treat to help keep cool, and they're called carpsicles. Right? But polar bears, lions, tigers, all of that type of carnivore, absolutely. It's like a kid with a popsicle. I've never seen them happier. That was great to see. So during construction, hauling and disposal, sediment project management. Right? You can see on the right how dicey it can be. Make sure if you're going to dredge, your contractor is top notch. And on the right, you can see the dredge material, and as it's drying out, it's being spread out. After dredging, you might have to do some restoration. That's usually budget driven, not permit driven. All right. Temporary structures come out, such as access roads. Disposal management, you might have to do some grading. You can't just dump it in a pile. You might have to grade it. You might have to shape it, things like that. Riparian buffer restoration, where your machines came in and out, you might have to repair that back to status. Fish habitat, now's your chance. That picture that was just totally bare, well, while things are bare, if you want to add habitat, now's your chance. Right? It's very easy. Walk out there, place it, or have your machinery contractor place it while they're out there. Right? But it's permanent. And then you might want to think about fish stocking after the fact, depending on if you did a salvage or not. So that's dredging in a nutshell. Switching over to a lake and watershed management plan, EPA dictates 9 steps. These are your 9 steps. If your plan doesn't address every step here, it may not get approved by town, county, state, regulatory agency, EPA. All right, so those are the things you really need to keep in mind if you're doing a plan. Oh, sorry, Mike. This will be posted, right?
Yes,
Yeah.
I'll put it on the website.
Yeah, and I can email it to anybody that needs it. So why do you need a plan, right? So how many of you here have had your lakes suffer from any of this? HABs, excessive vegetation growth, taste and odor, if you might be a drinking water source as well, degraded water quality, imbalanced fishery, erosion, watershed loading, funding. I can't tell you how many times people go to different places looking for funding, and the first question is, do you have a plan? And if the answer is no, guess what your answer is going to be? Probably no. So my approach to lake and watershed management plans after 30 years is these 11 steps. All right. Historic file data review, a bathymetric assessment, which is needed not just for dredging, but for hydrologic modeling. I'll get into that in a bit. Watershed delineation and mapping, watershed modeling, which is basically water and nutrients, field data collection, in-lake, watershed, stormwater, trophic state analysis, watershed assessment, where we go out and look for projects, a draft plan, get feedback. Stakeholder feedback is key, right? Don't just have somebody who's going to say, I'll give you a plan and walk away. Get feedback. There might be things that person may have missed, all right, that local residents know about. Finalize your plan, and once you have your plan, now it's a funding tool. So what you're using the data to understand: internal sources of nutrients, external, which is your watershed, stratification and DO depletion, stormwater impacts, sediment sources. If you're looking to dredge, guess what? You're going to dredge, but if you don't do anything in the watershed, you're going to dredge again. Just a matter of how long. All right. Biological interactions, use impairments, things like that. These are the things you need short-term and long-term. A hydrologic budget, what is that? Right? How much water's coming in? How much water's going out? Why is that important? Because if the plan makes recommendations that don't match your flow, you're wasting money. I'll give you an example. How many people have had milfoil? Basically everybody. All right. Do you remember the days of not that long ago when you would use sonar, which is a fluoridone-based product to treat milfoil? All right. Sonar needs a 30-day contact time. If your lake flushes every 4 days, putting sonar in, just throw the money out the window. It's easier, and it'll save you less time, and you don't need a permit for it. All right. That's a good example. If you need to know how often does your lake flush, all right, and flushing means how often does it completely replace the water every time. I did a talk about 15 minutes up the road. We did a hydrologic budget for a lake. Turned out it took 2 years for that lake to completely flush and become anew, if you will. And everyone was like, oh, 2 years, wow, that's a really long time. And I said, yeah, think of that every time you pee in the lake. And there was a bunch of faces that went, yeah. So that's a key, right? You can't make in-lake management recommendations without knowing how often does the lake regenerate. So what does it influence? You're mixing horizontal, vertical, retention time, bringing in aquatic invasive species from somewhere else, right? That's possible. Sediment infilling, algae blooms, restoration efforts. The key here, and I'm not going to read the whole quote, but connected waterways are a source of aquatic invasive species, all right? So if your management plan is going to address invasive species, hydrology is a very big part of it, especially if you're connected to somebody else, all right? How many of you all have flowing inlets? Where do you think they're coming from? Somewhere else, right? That's all you need. So another thing, nutrient loading. I'm going to focus on phosphorus because it's the main nutrient component. Nitrogen is just as big, but for brevity, I'm going to try to just stick with the phosphorus. A phosphorus load strongly determines the extent of your in-lake productivity. More phosphorus, more algae and SAV growth. It's very simple. If we figure out in a management plan that your lake has too much phosphorus, your lake has to go on a diet, right? You want to cut down that food source. Remember the getting punched in the face thing? Well, if you get rid of the opponent, guess what? You don't get punched in the face anymore. So a lot of restoration efforts are really geared towards reducing your nutrient inload, phosphorus, nitrogen, and suspended solids. All right, and I think a lot of you probably understand a lot of what's on here already. It can vary seasonally, it's internal and external, but the cornerstone of a successful plan is a lot of the modeling. Now let me give you a couple examples here. This was a phosphorus load we did for a lake. This was a Somerset County Park lake. The majority of the watershed was forested, not a lot of residential development. So on the left is acreage. And you can see most of it was forest, 68.9, right? Not a lot going on in terms of development, residential, commercial, industrial, not much, mostly forested. Here's a residential lake up in Sussex County, all right? And you can see not so much forest, but low density open space, which was considered larger scale residential homes, and low density mixed space was like your typical Main Street small town business district. But you can see here, between those two, it was 90% of the watershed, right? Now, going back to the forested watershed, here's the actual phosphorus loading. And you don't have to worry about the numbers on the left, the kilogram numbers, but look over on the right at the percentage. And you can see the biggest percentage here of phosphorus is groundwater, right? Not a lot you can do about that. That's a natural spring-fed lake, right? But everything else was fairly straightforward. Maybe up top, the hay and pasture, maybe you can work with the agricultural people and try to knock that down a little bit. Go back to the residential, same thing, percentage on the right. 93% phosphorus septic systems, all right? So when your management plan talks about septic management and a pump out program and inspection programs, this is why, all right? EPA has shown, and the literature shows, a pump out program of every 3 to 4 years can reduce phosphorus 30 to 40%, even in a perfectly functioning septic system, all right? Why not? Can't hurt anything, all right? But then you get into private property and people's rights and taxpayers, and that's where it gets messy. So when we compute the phosphorus load, you look at an annual load. You're looking at the big picture. You know, your field data provides a snapshot of existing conditions. I can come out and sample your stream. The next day it might be totally different. Week after that, totally different. All right. The model data shows the big picture. The field collected data is usually the fine tuning. But when you do a phosphorus load, it accounts for all sources, external, internal. You account for reduced nutrient loads. If you have a wetland upstream,
Could you just come back on the last, on what you said a minute ago about, so are you saying that it varies greatly in the course of the year?
it can.
But what was your, I'm not trying to put words in your mouth, I'm asking, what were you saying in terms of the, you seem to be saying there was a time-based model.
Yeah, so the models are based off of 30-year precipitation records, right? It shows you things on an annual basis, right? When this, you know, in the winter and spring, when the precipitation is high, and in the summer and fall, when precipitation is low. The models show a 30-year average of precipitation and show loading can vary, right? More phosphorus can be washed in at different times of the year, right? So just relying on, hey, we have somebody that comes out and samples once a week. If they're sampling once a week for 6 months, great, right? If they come out once a month, they're getting a snapshot of the big picture, right? So I might come out and say, and get a sample and it's clean, and say, you're fine, no worries, right? But the big picture tells us otherwise. That's what we do is if we were to sample that stream, we use that data to fine tune the model a little bit. The model was, you know, we'll run the model and it says, you should see this. When we do our sampling, if we don't see what the model says, then we try to figure out why. That's like where I'm going with that. When you compute your phosphorus load, like I said, you're looking at external sources, internal sources. Anybody here have bottom anoxia or aeration systems or things like that? Well, there's a reason why, yeah. You can reduce your nutrient load. If you have wetlands or upstream lakes or ponds, those can act like sponges and take phosphorus away. You bring in your models or the hydrology. We happen to use AV Guelph and Wiki Watershed a lot. So the model shows the big long-term picture, right? But you don't want to discount the monitoring. In situ data, discrete data, plankton data, SAV data, general observations, that's your day-to-day growing season type of stuff, right? That's just as important, right? In situ data especially, if your bottom goes anoxic, that's internal loading. If you don't have that data, you can't calculate that and add that to your nutrient budget. That guy on the left graduated college last year. He's also a lot bigger than me now. So here's a good example of monitoring. In this case, we're doing vegetation data. You see the lake? That's water chestnut. This particular water body went to this happens to be in New York, but they went to the state DEC to say, we need money to dredge and get rid of the chestnut. You know what the DEC said? You have a plan? They do now. They've been dredging since. So, as question? No? Joke? Okay.
Chinese restaurant.
Yeah. Listen, you want to be a billionaire? Figure out something to do with milk oil. Besides compost. All right, so once you have your models, and once you have your field data, and once you have your watershed, what do we do then? It's a watershed assessment. It's based on the models and data. We look at best management practices, green infrastructure, bioretention, lot-specific scale. All right, 9 times out of 10, there's not a smoking gun. There's a series of little things that add up to big numbers. Some examples: wetland buffers, riparian buffers, aquascaping, rain gardens, floodplain connection. All things you can do in the watershed to reduce water and nutrients coming into your water body. Right? Now people think, well, if I reduce the water, I'm not going to flush. No, no, no. You want the water infiltrating, which will still end up in the lake with surface water, groundwater interchange. So here's a typical picture from a plan. Right? This is a lake up in Sussex. We looked at an area of a public park. There's a lot of space to do a lot of things, all right? And we mapped it out for them. Hey, you don't have to reduce usage of the park, but you've got a lot of empty space that's vegetated lawn, or that's parking lot, or that is sheet flow coming off the parking lot and not going anywhere other than a direct channel to the water body. There are things that can be done, and here's some examples, all right? And I forget which ones were which here, but it just shows this is a typical picture in a plan, all right? A watershed plan will probably have 50 to 75 of these types of pictures in it, depending on how big the watershed is and what's in the watershed. Here's another example. This is Lake Wawayanda, all right, which is a public, state public water body, all right? Yes, there's picnic tables. Yes, there's lots of open space, right? But all that open space, in terms of stormwater and nutrient budget management, that's like a blank canvas for an artist, you know, in terms of us, all right? But so you've got to balance user needs, recreation needs, public usage, your stakeholder dues member usage with the science. That's the hard part. So let me give you another example. And you'll notice here on the upper right, this one is funded. It was paid for. This is the Ryerson Middle School in Ringwood. Ringwood did a plan. New Jersey Highlands Council funded a watershed plan for the entire borough. All 6 lakes in the plan are private. The plan included monitoring of all the lakes as well as all the watersheds. All right, funded by the State Highlands Council. We did all the work. This particular recommendation for the school, you had a parking lot recommendation, you had a vegetated meadow buffer recommendation, and you had a rain garden recommendation. All right. So the plan gets funded, we complete the plan, the Highlands approves it. Now Ringwood's got a tool in their hand going, where can I look for money? About a year later, 319 program comes around. We tried 319, they were denied. A little bit after that, there was a stormwater grant program that came out. We literally just recycled that application, put it right back into the stormwater program, fully funded, $196,000, soup to nuts, right? Everything, permitting, design, engineering, construction, everything, fully funded by the DEP, right? That's great for them. But what it tells everybody else is that plan that was written by PH, funded by the Highlands Council, is now approved for funding by the DEP, right? In this particular instance, it was a bit of a low-hanging fruit because it's obviously township property, being that it's part of the township school system. We didn't have to worry about access easements or private property concerns. We took that project, recommended project, put it in front of a different regulatory agency, and they said, yeah, great, here's your check. That's the key, right? I call it, being an old hockey player, I call it playing the game, right? Science is easy, people are hard. And playing the game is making sure you've got the right relationships with the right people in the right places, and you'll probably be talking about this a little bit afterwards, to play the game, right? My wife's very, very Sicilian, right? There's a line in Godfather 2 that I love to use with regard to this stuff. Difficult, but not impossible, right? And that's the fun for me, is figuring out how to play the game. So we've already started on the project. On the right is the driveway that goes down. Well, that's a straight down slope that would go to Cupsaw Brook, which would go right to Cupsaw Lake. All right. Now the runoff from the school parking lots is going to go into what is in this area, which was just grass. I mean, it wasn't being used for anything. We made sure this isn't a gym class area, this isn't a science club area, and it was just mowed lawn on a slope, right? Essentially useless space. It's now going to be collecting all that rainwater into a rain garden where it'll get filtered prior to going to the Cupsaw Brook and eventually ending up in Cupsaw Lake. All right, and so all that water is going through a fantastic filtration source.
Was that all regraded to have it go to that grass area?
It goes there, right now it goes there on the natural grade.
Was it regraded to do that, or how did you prevent it from going down the hill?
What did you do?
On the blacktop.
Well, we haven't done, we haven't started construction yet,
Okay.
but it will be, yes, you're right, stormwater will be directed to that area.
What, like a speed bump or something to have it redirected to the grassy area?
Yeah, you can do, there's like minimal curbing here.
Yeah.
You can do curb cuts,
Okay.
which will then direct it in. But as of right now, yes, it kind of goes, sheet flows all to that corner, where then it then goes under this driveway.
Okay,
And the brook is on, you can't see it, but it's on this side of the road.
okay.
These are some examples of what it will kind of look like. This is not the project, obviously, but you can see what was normally just a strip of land between access road and parking lot is now going to be used. All right, the one on top, I'll be honest, I don't have the slightest idea where that was. That is one of our trucks, but I don't remember where it was. The one on right is actually a rain garden at Colorado State University. It's right outside the chemistry research building, actually. But just an example of how little lot scale size projects can add up to big results. So when you put the plan together, you base your decisions on diagnostic data, long-term, short-term, you prioritize, you develop your budget, look for your funding sources, which are part of the plan. You typically give a list of places to go for money, and you want to make sure you're cost effective. You distinguish between your symptoms and your causes. Symptoms, algae, plants; cause, too much nutrient. All right, again, punched in the face. You focus on correcting your causes. You make direct decisions based on the data, permits and approvals, what's going to be short-term, what's going to be long-term, such as dredging. And you review and make sure that you're being cost-effective on your return on investment. So some examples real quick. New Jersey Highlands Council. Since the Ringwood plan was approved, and Ringwood was the first to do this, every lake on this chart, or on this slide, now has a watershed-based plan with a little bit of a lake management plan included. Yellow is public, everybody else is private. All right. These folks did nothing. And I don't mean that in a bad sense. It was the townships that went to the Highlands Council that said, we want to do this, how can we do this? And then the lakes were picked through a bit of a selection process based on technical definitions, asked if they wanted to be included, they did, they're in. All right. Anybody from these lakes here? All right, so next time you go to your township council meeting and you yell at them, think about that. Because when grants come available and the township has a plan in their hands and are able to go get funding, they're going to go, well, these people yelled at me. These people helped me. Who do you think they're going to want to work with? Remember that relationship quote and playing the game quote? That's what I'm talking about. The Highlands Council Direct, right? The Highlands Council put an RFP out about a year and a half ago and just said, hey, we want to give out some watershed, lake and watershed plans. Who's interested? All right? Well, and the first 4 here are Roxbury Township, the second 8 are Jefferson Township, and the last one is the Mountain Lake Community Association. We teamed with all of them to write a proposal, got them grants. These plans are underway. We just wrapped up data collection now. About half of these are private. But again, the township was the catalyst to get the funding. The Highlands cannot give money out to private entities. They can give it to municipal places.
Excuse me, what if you're not in the Highlands?
There's some other options. I'm getting there. I knew that was going to be a question. Here you go. NJDP in 2022 had lake restoration grants. These are the ones I'm currently working on, right? Now, a lot of these are public, but here's an example. If you look at the Point Pleasant one, they're doing 3 lakes. Lake Louise is private. It's literally an access point off the Manasquan River inlet, specific to homeowners with boats, right? Again, a relationship with the town where the town was able to go to the state and say, we want to do this, can we have money? And the state said yes. All right, so here's one way, another way of playing the game. Here's a couple more examples, right? Now, in this case, it's a little funky of an example because Lake Apacong is public. Lake Apacong is about to do a 976-acre nutrient reduction treatment program next week, fully funded by the state. All right. Now, yes, it's a public water body, but there's a few people that live around Lake Apacong. All right. So this is work being done for their lake. The Biochar Socks for Docks program, right? That was a joint program between the Commission and the Lake Apacong Foundation, which is a non-profit group, remember that, where they got grant funding for biochar socks for docks. Anybody who lived on the lake was eligible. You could come, pick up these socks at no cost, and these socks are basically filters. They're carbon material inside of a burlap sack. All they had to do was basically zip tie it to their dock, give it back at the end of the season. Those socks acted like, almost like aquarium filters all summer, all right? The residents didn't have to do anything except pick it up, tie it, bring it back, done. And then there's an outfall maintenance dredge program going on where all the municipalities receive money to do dredging at various points of the outfalls, stormwater outfalls around the lake. All right, again, oh, go ahead.
Could you just, after you're done with that sentence, could you just characterize what Lake Apacong is doing? What nutrient inactivation project means?
Yes, it's an alum treatment. All right, so they have a big internal loading issue. Alum binds phosphorus, all right, and it'll grab it and sink it to the bottom. And then once it lays on the bottom, it can help reduce release of phosphorus from the sediment as well. So they're treating with alum, right, which is literally liquid aluminum. Right. You have to do it at a certain dosage, you have to be careful, et cetera, et cetera. There's all kinds of permit issues. But there's other nutrient inactivation you can do. Phoslock was a big one, which is lanthanum clay-based. There's Utrosorb now, which is the same thing. Those are a little easier to work with in terms of ecological issues, but they're much more expensive. All right, so alum is still an effective tool. It's much cheaper, but you have to, there's precautions and monitoring that has to happen as you do it. The county park commissions, all right? This is an often underutilized funding source. All right, the top 4 here happen to be with Mercer County. All right, they all received lake and watershed management plans with county funding. The bottom 2 are Somerset County. Those lakes got their funding from the Highlands Council, all right? But the key here is the bottom 2. The Somerset County Parks Foundation teamed with Somerset County Department of Engineering to get the money. The money went to the engineering department, who then gave it to the foundation, which is the nonprofit, to then do the plans. Right? There's a lot of relationship stuff that happens with this kind of funding. The Army Corps of Engineers, all right? Big time underutilized funding source. Lake Apacon, again, a little bit of a wonky example. They just got funding through the, it's called ERDIC, the Engineer Research and Development Center. They're going to be doing a massive incubation methodology sediment sample study, which is going to study how does blue-green algae overwinter in the sediments. All right. One of the things we're finding in the last few years, blue-green algae has a competitive advantage for multiple reasons. Well, one of the latest ones is we figured out that it can sit on the sediment all winter, and it has a vegetated cell called an aconite. It's essentially a cocoon, and it can feed off the phosphorus in the sediment all winter. So when things warm up and get sunny in the spring, they're off and running. Right? It's a competitive advantage. Right? Instead of just coming out and blasting it with copper, there's a theory that it might be better to treat the sediment early in the season versus letting it even begin growing to begin with. All right, so Army Corps of Engineers put out the funding to do this kind of a study. Apacon went, yeah, we're in. That study could happen anywhere. NIFWF, National Fish and Wildlife Foundation. We're in collaboration with them. It's already underway with a local nonprofit who was the sponsor of the grant. The money goes to the nonprofit. The nonprofit then dishes it out to whoever. With us and CUNY, New York City College, we're doing it's going to be a remote sensing study using drones on the water sampling for the development, to be able to predict the development of HABs, as well as the type of HAB, planktonic versus benthic. And it's going to be used in sections along the Delaware River where potable water suppliers are pulling off the Delaware. All right? One of the things we have found in the last couple of years during drought conditions, HABs can actually form in flowing water rivers if levels are low enough and sunlight is hitting the bottom. All right? And I didn't put the picture in. I got a great picture for this. At the New Jersey American Water Plant, where the Raritan and Millstone rivers come together, one is pure green, one is crystal clear. And it's right where they mix, where the intakes are. All right? But again, the money came from NIFWF. It went to the nonprofit, who is then distributing it to the professionals and the academics to do the work, benefiting private companies in this instance, water utility companies. All right? So it wasn't a case of being a municipality or a public water body. It's playing the game according to the definitions of everything in the regs. You got all that, right? All right, so here's some places to go for resources. North American Lake Management Society, EPA, Office of Watersheds and Wetlands. NJCOLA actually has a nice website with a lot of information. And I apologize, I should have said where to go for resources other than the NJCOLA website, because I know you've got a lot of good stuff too. But the DEP actually has a grant and loan program homepage, all right, where a lot of this stuff will come out. All right, but the real key, again, is having relationships with the right people in the right places, so that if something comes available, you can say, hey, can we do this? And if we can, how do we do this? Right? And it might take a mad scientist like myself or Dr. Love now or others from our company to go, what if we A, B, C, D, E? It's worth a try. All they can do is say no. Well, we've had far more yeses than nos, believe it or not. Simply because a lot of times people don't know about the grant programs, or people don't apply for the programs. That being said, I do want to caution, grant management, and Sabine will tell you. Want to talk about the SAGE website? Yeah. It can be, put your head through a wall at times, you know, so there is that side of it. But again, it's having relationships in the right places with the right people that really leads to grant funding. And while you're all private lake associations, difficult, but not impossible. All right, I just want to close with, today is homecoming at Colorado State. My son just graduated. I was involved with football while I was there. They're playing New Mexico. I'm not going to make the game, obviously, but I just got to say, go Rams. You know, so. Questions?
Yeah, it'd be nice if someone else paid for it, of course. But basically, let's say you have a 100-acre lake.
Mm-hmm.
How much is a watershed assessment plan? Generally, I know it's a ballpark between what and what.
They can get expensive. I'm not gonna lie. If you're doing a bathymetry included, if it's one water body, you can be anywhere from $50,000 to $100,000. All right, with all of the engineering and modeling and mapping and monitoring and lab data and everything, soup to nuts. The Highlands ones have been very efficient because my crew is hitting sometimes 2, 3, 4 water bodies in a single day. All right, so the Highlands ones have big price tags, but it's mostly because of the mapping and modeling. All right, the Somerset County one was 2 water bodies. All right, smaller water bodies. I think that one, including bathymetries, that one was like 50 or 60,000 total.
And the other thing is, when you guys come in and do the plan, and let's say they decide to go ahead with the plan, do you guys act as the point for getting the grants? In other words,
Yes.
You guys, that's part of your expertise that you bring to the project.
Correct. So in terms of writing grant applications, we have a couple different processes. If I'm writing it for a town, like all the Highlands grants for towns, the town gives me a resolution from their council giving me permission to write the grant for $0. It is written in the resolution that we will receive $0 to write that grant. However, the resolution also promises us the work under a professional services agreement because we wrote the grant for free. All right, so we can write the grant for free. We just ask for that commitment that it comes to us if it comes in. We've also been paid to write grants. So we'll get paid, we'll write the grant. If the town gets the grant, at that point, they're free to go to RFP or public bid, all right, because we were paid to do it. So then it's totally up to the town at that point. And we've done it both ways.
One more thing is because that is part of your expertise, something you bring to the table. How successful are you with those?
It depends on the funding program. We're of all the New Jersey-based approved watershed management plans, I think we've written about 2/3 to 3/4 of them. All right, we do. I'm not trying to sound big-headed here. We have a very good reputation with DEP regarding watershed management. All right, and lake expertise. The bigger, more national programs, it's probably about 50-50, because maybe they don't know you, maybe that you don't have that relationship, or maybe it's a national program versus a local, regionalized state program. All right, so not as successful there, all right, but within the state of New Jersey, excellent reputation. In the Northeast, Mid-Atlantic, decent reputation in terms of public awareness. A national program, you're submitting just like everybody else, We do write 9 times out of 10, we'll write the grant application for free, pro bono, public or private recipient, doesn't matter. Again, with the promise that it comes to us if it comes in. Oh, lots of questions.
Hi, Christine at Stockholm. We communicated via email a couple of years ago.
Yep.
We're in Hardiston Township.
Mhm.
Did they ever cooperate or listen to you, or they didn't listen to us?
I did not receive any calls or emails. One thing I do have to caution, with the Highlands program, I, as a consultant, cannot go to the Highlands Council and say, please give this township money. I have to do my protocol through the township. The township then has to go to the Highlands Council with the official submission and request. All right, there is a protocol. All right, I can serve all the food on the plate, hand it to the township, The township's got to then take that plate and put it in front of the Highlands. All right, so there is protocol. I've reached out a couple times. I did not hear back. At that point, we cut our losses and keep going. In the back?
Yes. Chrissy, biochar socks for dogs, is that specifically a program for Lake Pacon, or is that something that can be used? Is that an individual program that Princeton Hydro?
That program was specific to Lake Apacon because the commission and the foundation teamed up on the grant to get the funding for the socks. All right, so that particular program was specific to Lake Apacon. That being said, that program can be used in any water body in the state.
Can we go through the township, because we're part of the Highlands, the West Milford Management, Watershed Management Plan, can we go through the township to try to set something up like that at our lake?
Sure. Sure. It's just a matter of where the funding source is. There was more.
Could you talk a little bit, you mentioned the sediment sampling and analysis.
Mhm.
And I, maybe I speak for others too, that there's a little fear if we've been using, say sonar, which you mentioned,
Mhm.
for years, that, when you dig up that sediment and have it analyzed, suddenly you're opening up a can of worms. Like, what's in that sediment? It comes into play, like, with where you're gonna dump it. Basically, the nightmare is it's full of toxic stuff.
Right. So you're worried about paying for sins of the past.
Well, I think the question is it possible to generalize? A lot of us have similar sizes of lakes. We've been doing the same kind of things.
Mhm.
What do you find when you analyze that sediment? Is that nightmare true, or is it just a baseless fear?
Yeah, so a couple things. The sediment sampling and analysis plan is a checklist item. It is required if you're going to get dredging permits, right? So there's no getting out of it. All right, now I understand your fears. The question is, if we do the sampling and we open up a can of worms with regards to what's in the sediment, what happens to us? All right, a couple things. Your SSAP gets you to the point where you can then get a scope of work for dredging, right? If your plan gets approved and you do the sampling, at that point, nothing is obligated for you to dredge. That's where you make your decision, hey, can we afford to dredge based on what we have to do with the sediment, right? The Clean Water Act, specific non-point source pollution, section 319, protects you that if you do sampling and you find things over New Jersey residential criteria, you do not have to do anything at that point because you do not know the source. All right, and I know some of you are thinking, well, crap, we treat with copper sulfate for algae. What if the copper is in the sediment? Because that's the main question with this. If you do your sediment sampling and you're over residential cleanup standards, at that point you do not have to do anything. All right, you just know what you're going to have to deal with should you choose to dredge. All right, you do not have to go in and do a cleanup, so to speak. All right. I also want to point out the residential cleanup standards for soil in New Jersey. It's based on you eating a teaspoon of soil every day for 30 straight years. All right. If you're eating a teaspoon of soil every day for 30 straight years, you got bigger problems. But it gives you the answers of how do I manage the sediment? Can I put it here, or do I have to truck it somewhere? If you're trucking it somewhere, it's dollars.
And that's the copper sulfate scenario that we're trucking it somewhere. Is that it?
Right.
But are you finding generally that the sediment sampling, is yielding, the sediment is fine? Or are you finding a lot of nightmares?
Yeah, I'm sorry, I forgot that part. Normally what we find is what's called PAHs, polycyclic aromatic hydrocarbons. They are classic materials found in asphalt and roadway runoff, right? And the problem is their standard is very low because they can be toxic. So their standard is low. Any lake receiving stormwater from a network of roadways, this is one of the most common things we find in New Jersey, is PAHs. PAHs usually means you're trucking it somewhere, right? Because PAHs, polycyclic aromatic hydrocarbons. They're semi-volatile compounds, typically found in asphalt, in roadway, in seal coating, everything you need to drive a car on. All right. We also find a little bit here and there metals, which is very common, again, with a roadway network and tire erosion. You know, tires have metals in them. As tires wear down and it gets washed into lakes, we find it in sediment. Those are the two most common. Every lake is different. You might have a little thing specific here and there, but those are the two most common. Metals, specific to heavy metals, and PAHs. Back there?
I have a question whether or not how to deal with the DEP. Like maybe other lakes have had the same problem. We've had buku studies from Princeton Hydro going way back to Coastal, which is precedes.
Yep.
Steve, Fred, both know the lake. Our problem is biomass. So 2 years ago, we were awarded a grant from the DEP for hydro rating.
I know where you're going.
Never got a dime of it yet. This year, they tell us there will never be any hydro raking in our lake.
You're at Swartzwood, right?
You got it.
Yep. So,
And we said, okay, give us a demarcation of areas that we can't work on. No, we can't tell you that because we're threatened and endangered, and you might damage our threatened and endangered. But we can't know where they are.
yeah. So the question is surrounding hydro raking, right? And unfortunately, you're a little bit of a special case, right? Because your Swartzwood Lake it's a public lake, and it has a threatened and endangered plant species on it, right? So it makes a little bit of a logistical nightmare in terms of regulatory decisions down at the state. All right. The state has been giving out grants in the last couple of years specific to hydro raking. Right? Hydro raking is removing biomass material, whether it's dead or alive, by the root systems. So you're kind of blending up the sediment. It gets the organic vegetation out by the root systems. You remove the organic vegetation, and the sediment theoretically settles back in. All right. Up until a few years ago, you did not need permits to hydro rake. Hydro raking is now a permitted activity. Right? Here's the problem. There's not a clear permitting pathway yet. Right? Historically, and historically I mean within the last few years, the DEP has kind of said, you're disturbing sediment, that's dredging, but you're not removing sediment. So it's not dredging. And there's been a bit of a back and forth in terms of which way to go forward. There's not a pathway forward yet, unfortunately.
But we know we have the lotus, which Bob Particus says is native, it's TNE. Every other state, it's an invasive, can't be sold, you know.
Yeah, that's...
Now they claim there are 5 or 6 other cases of a threatened endangered in the lake.
Yeah, unfortunately, I wish I could have an answer for you. Threatened and endangered comes from the new state of New Jersey, not us. So you're trying to navigate a permit process that isn't 100% finalized yet, but then you've got the added wrinkle of threatened and endangered species, which are the same if it was on land, you know, animal, plant, mammal, reptile, it doesn't matter. Right? If you've got T&E species, and all these species are mapped at the state, it's an added wrinkle.
Can we get access to that mapping?
If you go to DEP's homepage, I think it's called GeoWeb. I don't know if they will have specifics, like you said, because they do not give out locations. Like eagles' nests are a great example. Right? They know where all the bald eagles' nests are. They're not necessarily going to tell you, mostly because they don't want disturbance. You know, they want the protection of the species. So Swartzwood, unfortunately, is a bit of an added wrinkle. But in terms of hydro raking, the permit pathway isn't clear yet. The dredging pathway is considered too onerous and too expensive for what wants to be done, which is removal of organic and/or biomass that may already be dead. But we're still waiting, like everybody else, what is the feedback on that pathway? Right, we do have meetings set up with Katie Angeron, who's the assistant commissioner, I believe is her name, is her official title. She's basically number 2. We have met with the commissioner about this, and internally they are continuing to move forward. I just don't have those answers yet. But I have a grant, same situation. I have a grant with the Township of Moorestown, Burlington County, for hydro raking of Strawbridge Lake. When I submitted the grant, I outlined my permit pathway forward, which was the typical dredging permits. Now, that pathway is considered too tedious, too expensive. I'm waiting like everybody else. So, I wish I could help you further that way, but the T&E really throws the wrench.
I didn't realize the endangered plants voted and paid taxes. It's very enlightening to see how much respect they get from the
Yeah, yeah. Wish I could help you there.
If you find that you have some toxic materials in your sediment, and you have your own property to put them on, that the lake owns, can you use it, put them there, or do you have to send them out?
It depends on what's in it and how much, right? Because with regard to the standards, there are standards for residential areas and non-residential areas. The non-residential area standards tend to be a bit higher because the theory is no one's around, right? I'll give you an example. If you have a park, let's say, or public space area, you can, depending on what it is and how much is there, sometimes you can put it into non-residential areas, such as a park, with the theory that it's not going to be contacted every day. Now that being said, if that park has athletic fields, right, where the kids are going to play baseball or soccer or whatever, you cannot use it there because that's considered direct contact. Right, and there's a couple different sets of standards. There's inhalation, there's ingestion, there's dermal. It's a series of standards, and you pick your proposed disposal location based on the standards. Right, the key word is proposed because it has to be approved by the state. Right, and they keep track of there's paperwork you do after a dredging job as to, because it's my job to get the DEP to talk to each other. I get all my permits from land use. Dredging and sediment technology approves the plan and the sampling. After the fact, when the project's 100% done, I then have to do paperwork to tell dredging and sediment technology where everything went. All right? Because land use approved it, but land use won't tell dredging. I have to tell dredging. All right? So again, it's really a case-by-case basis based on what's in the sediment, how much do you have, how high is it over the standard or below the standard, etc. All right, you play the game, right? You can, a lot of times you might see residential developments, new residential developments, and as you're driving down the road, have you ever noticed a berm or a hill that has been built, right? You think it's for privacy for the residential development? Bullshit. The topsoil had stuff in it. They bulldozed it all to a certain area, capped it with clean soil, seeded it. Guess what? They got rid of the problem. And now they'll charge you 25% more because you have a privacy buffer. No, you just paid for the cleanup. Sorry, that was out loud.
So after there's a plan and everything, that's when you could go to try and get the grant funding. What are some ways that you've seen people come up with the money for the initial plan?
Again, different grant programs, right? Every example I gave, somebody else paid for. All right, so it's a matter of where is your lake? What programs are available? Are they local? Are they state? Are they a regional planning association? There's definitely ways to do it, including private finance, which is definitely not ideal for most of us. It might mean, given that you're a private association, you most likely are going to have to team with somebody, somehow, some way. right? And that might mean everything from setting up a nonprofit foundation to working with your town or your county or something along those lines. Or having a relationship with a different nonprofit. Musconetcong Watershed Association is a great example. The amount of grant money they've landed for projects from the Hapatcong water, they represent the Musconetcong watershed, which is basically the watershed of Hapatcong straight to where the river enters the Delaware. All right, so if you're in the Musconetcong watershed, you can go to someone like the Musconetcong watershed who is a nonprofit and is eligible for anything and everything. All right, but again, if you don't approach them with a relationship, they may not come to you.
Thank you. I just started a nonprofit for fundraising purposes.
Yep.
Because we used to do a raffle and we got shut down.
Right.
So then I started a nonprofit for it. So I just got, I just resubmitted the raffle permit, but because they got denied the first time. We're learning that, but that's good to know. All for, I guess, nonprofit grants.
Yeah, I mean, once you're, I mean, usually it's 501c3, but I know there's a couple different versions of nonprofits. Usually, when grant money comes out, you have to check who's out. There's always a paragraph, who's eligible. It's usually municipalities, nonprofits, academia, everybody but the people who are going to do the work, usually, so.
The bathymetric map, we can do it with depth. How did you do it to get sediment levels?
So most of the time we use what's called a dual frequency sounder, which is a fancy way of saying sonar. It's a piece of equipment, it's just below the surface of the water, and it sends down two signals. Right? The first signal hits the bottom and bounces right back up. That's water depth.
Yeah.
The second signal will go down until it hits what's called hard bottom. That's usually clay or bedrock in this area, and bounces back up. The difference between the two is your sediment thickness. It takes a data point once every second, right? So an 8-hour day, you get something like 12,500 data points, all right? As we're doing them, we also calibrate it by hand. So if the computer is saying, hey, there's 4 feet of sediment right here, we have our calibrated survey rods. If it doesn't show 4 feet, we figure out why not. Sometimes it could be noise, could be interference. You typically don't do bathymetrics during growing season because vegetation can make the signal go wonky. We usually do them in March, April, or October, November. But the sounder is great. There are situations where it's not the best. Shallower water, high vegetation, that kind of thing. But if you can do 80 to 90% of the water body with the sounder, that's all the hard work. All right, and then it's just GIS programs from there. I think HydroPack is the name of the program that creates those models and maps. The key is the sounder measures what's called unconsolidated sediment, which would be the stuff that has been brought in over the years, meaning this is what you would be allowed to dredge because you can't go beyond original hard bottom. So it's a bunch of toys that are really expensive and I don't touch.
All right, thanks.
Chris, I got a question about hard bottom. In the first decade of the 2000s, right, we only did two projects, one at the Beach 3 area and one at the Beach 2 area, where we basically dredged out the road sediment coming from the storm drains.
Mm-hmm.
But if I look at the history of White Meadow Lake, which was basically impounded during the early 19th century for mining. They needed water for the White Meadow Lake mines.
Yep.
And then around the 1870s, they let it drain back down into a meadow because all the mining operations went out to the Great Lakes area and they weren't mining that particular mine anymore. But then around the turn of the century, around 1916, it was impounded again, for somebody's for the mansion and the hunting lodge and the hunting club, etc. So since White Meadow Lake went back and forth between being a white meadow and being a lake, what is the hard bottom? Because is the hard bottom the top of the meadow when it was impounded again, or is the hard bottom the seat of the meadow that was underneath the lake. That was
Right,
accounted for mining.
The short answer there is probably going to be based on your dam design and drawings. Right, because most of the time you can't dredge beyond the original hard bottom in relation to adding that additional pressure on the dam. The dam was designed for the lake to be a certain depth and hold a certain amount of volume. Right, so your hard bottom is going to be based on that 99% of the time. All right, so in a situation like that where it was meadow, it was bog, it's kind of wonky because it's wet, but it's not really water. Your dam drawings are probably gonna rule the day.
But your fancy machines would still pick up what is considered hard bottom.
Right, right, ecologically.
Right.
Right.
Actually.
Yeah.
Yeah.
Yeah. But again, everything is going to be geared towards public safety and dam.
Right.
Yeah. So we good on questions? One last thing. Anybody got geese problems? I got a solution. We don't have geese problems. You know why? Mountain lions.